Section 3.5 should have been pretty easy for you. Just empirical molecular formulas. You guys remember how to do that? If you don't, you will as soon as we go over it, I think. But really, the high points I want to hit here, the empirical formula rhyme from last year. Yeah, see, this probably isn't going to let me. Oh yeah, well, percent to mass to mole, divide by small, multiply till whole. I'm going to have to put that over here. Okay? And that basically gives you the steps in an empirical formula. So if you are given a percentage of the elements in the compound, then you can use that, change that into masses. Now, do we remember how we go from percent to mass? Let's say I've got a compound that's got, I'm just going to make up numbers here, 52% carbon and 48% hydrogen. Okay? And how would I get from percent to mass? Percent to mass. Well, we have to do both of them to figure out the empirical formula. We have to do both carbon and hydrogen. Okay, so what are you going to assume here? We make an assumption when we go from percent to mass. Do you remember what it is? Yeah. You don't have to assume a 100-gram sample, but just to make life easy, let's assume we have 100 grams. If we have 100 grams of this sample, 52 grams is carbon, 48 grams is hydrogen. The only thing that really matters is the ratio there, okay? So that gets you from percent to mass. Once we have 52 grams of carbon, 48 grams of hydrogen, the mass to mole step should be fairly easy, right? You just go from whatever that mass is, divide it by the molar mass. That'll give you the number of moles. Divide by small. So let's say that you end up with 2.2 moles of the carbon. Again, I'm just making up numbers here. And 1.1 moles of the hydrogen, okay? So you would divide by the smallest, which is the hydrogen here. And actually, I did this backwards. I should have done 1.1 moles of carbon. Doesn't really matter. Okay? Divide by the smallest of those two. That's divide by small steps. So that's going to come out to 1 when you divide this by 1.1. So that decimal keep going on. And this is going to be 2. Okay? So the empirical formula for this would be CH2. See how easy that is? Okay? Actually, CH2 doesn't exist, but whatever. I should have done something where it ended up C2H2, but then it would have just ended up CH as the empirical formula. But that's the idea. And then if you end up with like a number 2.5 here, then you have to multiply both of these by 2 so that you would end up with whole numbers, because we can't put half numbers in our as our subscripts. That's just a little awkward. Okay? All right, so that's that. These sample exercises basically just take you through how to calculate empirical formula, how to do molecular formula. Do you guys remember how to do molecular formulas? Okay, that's the part we need to talk about a little bit. So let's say that I set this up the way I should have, and I ended up with CH as my empirical formula. Okay? So then the question also tells you that when this compound, whatever the compound is analyzed, the molar mass of the actual compound is 26 grams per mole. Okay? So that's the molar mass of the actual compound. Here's your empirical formula. Is the empirical formula the correct formula for this molecule? No. And how do we know? What's the molar mass of CH? 13, okay? This is 13 grams per mole. That's not the same as this, right? So what would the actual compound be? You have to multiply this empirical formula by 2. You end up with C2H2, okay? Do you guys remember how that works? Empirical formula is going from empirical to molecular. Usually the students I have coming into AP, they need just a very brief refresher on that, and then everyone's good with those. Because even in honors chem, those aren't that hard, right? So, all right, so just a couple things to look at here. On the course description, an empirical formula is the lowest, this is 1A2B, the lowest whole number ratio of atoms in a compound. Two molecules of the same elements with identical mass percent will have identical empirical formulas, okay? So if their mass percentages are the same, they'll have identical empirical formulas. But the question here is, just because they have the same empirical formula, does that mean they have to be the same, exact same molecule? No, okay? Because there are certain things, I'm trying to think of a good example here. A lot of the organic compounds. So, okay, here we go. Well, let's see, even this, the empirical formula for that doesn't really exist. Oh, yeah, what am I doing? Okay, C6H6 and C2H2. Those are both actual molecules that exist, okay? Their empirical formulas are both CH, right? So they have the same empirical formula, but they're not the same. Does that make sense? So there are scenarios where just because they have the same, so these would have the same percentages, right? But they're not going to be the same, they're not going to be the actual same molecule, okay? And then this, I think we're going to be better off talking about this in the context of this practice worksheet. But this is how to calculate percent purity. Now, we didn't really talk about that last year, but it's very easy. It's a typical percent type calculation, okay? So I'm going to give you these two worksheets now. You don't necessarily have to do anything with them tonight. If I were you, I'd enjoy a night without homework, okay? Actually, tell you what, since you don't have to do them, just don't worry about them for today. I'll hand them out tomorrow, and then we'll get going on the lab, okay?
Hate you.